Hey students, for today's 4.3 practice problems, we gave you guys 3 different difficulties to try and work through. I will go through all 3 difficulties in this video, so if you didn't try some of the harder ones, feel free to stick around and watch me work through them and see if you can follow along. For the first, we're going to start off out at normal difficulty. The first problem we had is 3 plus a is equal to 7. To isolate the variable a, I need to subtract 3 from both sides, so you can see that I do that here as well here. When I take 3 away from the left side, I know that this turns into a 0. And when I take 3 away from 7, I am left with a is equal to 4. For the next problem, I have b minus 2 is equal to 9. I will, because I have a negative value here, I need to add 2 to both sides to get rid of this 2 on this side. When I add 2 to 9, I am left with b is equal to 11. For the next problem here, I have c plus 9 is equal to 14. I would, to isolate my variable c, I would subtract 9 from both sides. I know 9 minus 9 is equal to 0. 14 minus 9 leaves me with 5. Therefore, I know my variable c is equal to 5. For the next problem, we have 6 plus d is equal to 17. Again, I have a positive value here for 6, so to isolate my variable d, I want to subtract 6 from both sides. There I am left with d is equal to 11. For the next problem, we have e plus 6 is equal to 6. I would subtract 6 from both sides of this equation to isolate my variable e. That would leave me with e is equal to 0. The last problem in the normal category, we had f minus 104 is equal to 2. To isolate f, I would need to add 104 to both the left and the right side. So when I have negative 104 and I add 104 to that, that is actually equal to 0. And when I take 2 and add 104, that leaves me with f is equal to 106. At this point, we are getting into the hard category. The first problem in the hard category, we had 3.8 plus a is equal to 7.0. I have a positive value here next to my variable, so I know I'm going to need to subtract the opposite of that from both sides. So I subtract 3.8 from this side as well as 3.8 from my value of 7.0. That leaves me with a is equal to 3.2. Here, I will show you my subtraction. I had to borrow from my 7 in order to start my subtraction when I line up my decimals. So I crossed out my 7, turned that into a 6, and I was left with 10 minus 8. I know that equals 0.2. And then I had 6 minus 3. Remember, we can carry over our decimal point, and before I get into my 6 minus 3. So I can bring over my decimal point, and then I would do my 6 minus 3, and that leaves me with my 3. For the next problem, we introduce some fraction work. We have b minus 2/3 is equal to 9/3. So to isolate my variable b, I could add 2/3 to both sides, both the left and the right. And when I am adding fractions, I can add straight across as long as they have the same denominator, which they do in this case. So I know I can just do 9 plus 2, that equals 11, and the denominator stays the same. So I'm left with b is equal to 11/3. Sweet. For the next problem, we had c plus 45 is equal to 87. To isolate the variable c, I would subtract 45 from both the left and the right side of this equation. That would leave me with c is equal to 42. One thing I will say at this point is that the last three problems of the hard section are the first three problems of the lunatic section. So you will see some overlap here, and I'll only go through those problems once. The first problem there is 6.5 plus d is equal to 17.3. So to isolate my variable d, I would subtract 6.5 from both the left and the right side. When I do it from the left, that makes a 0, and I'm left with just d. And on the right, I have 17.3 minus 6.5. I lined it up here so I could work through my subtraction a little easier. Remember, when you're subtracting decimals or adding decimals, you want to line up your decimal points. Here I have 0.3 minus 0.5. I know I'm going to need to borrow from my 7, so I cross out my 7, turn it into a 6, and carry a 1. That leaves me with 13 minus 5, and that leaves me with an 8. I'm then left with 6 minus 6, that's a 0. Then I'm left with 1 minus 0, and that's a 1. That leaves me with the value of d is equal to 10.8. Sweet. For the last two problems of the hard, or the second and third problem of the lunatic section, we have these problems right here. For this one, we had e plus 1/3 is equal to 6. So I would have to subtract 1/3 from both the left and the right side. One thing I know about the value 6 is that if I'm going to subtract that fraction from it, I have to convert it to a fraction itself. The way I did that is I put an imaginary 3 underneath my 6, and then I knew if I was putting a denominator of 3, I would also have to multiply the top by 3. That would leave me with 18/3. I know 18/3 minus 1/3 is then equal to 17/3. Therefore, that's how I got my value of e is equal to 17/3. For this problem, we had f minus 10.4 equals 2.4. So because we have a negative value here, we can add 10.4 to both sides to isolate our variable f. So if I add 10.4 to the left side, that gives me just f remaining. And then on the right side, I take 2.4 plus 10.4. Again, I lined up my decimals here. 0.4 plus 0.4 is equal to 0.8. Then I'm left with 2 plus 0 is 2, and then my 1, leaving me with f is equal to 12.8. Now on to the final remaining three lunatic problems. These definitely get more complex and are two-step problems. So for the first one, we had 2x plus 1 is equal to 15. The first thing I did here is subtract 1 from each side, leaving me with 2x on the left, and then on the right I had a value of 14. The next thing I knew is that I needed to get rid of this 2. Remember, when we have a coefficient in front of a variable, that implies multiplication? That means that if I divide 2 from both sides, I can isolate my variable x. That would leave me with x on the left, and then I would be left on the right side with 14 divided by 2, that equals 7. That means x is equal to 7. So the one thing I do want to point out, that this is a two-step problem. Here was the first step, and here is the second step to solve for my value of x. For the next problem, we had 18 minus 2x is equal to 5. Now, one thing I realized about this is I had a negative value in front of my variable. The first thing I did to isolate that is I knew I wanted to get a positive value there, just to make my math easier down the line. So what I did is I actually added 2x to both the left and the right to bring it over to the right side of the equation. This will make our math down the line much, much easier. From this point, I was left with 18 is equal to 5 plus 2x. At this point, I wanted to isolate my variable. Even though it's on the right side, I'm still able to do that. I can do that by subtracting 5 from both the right and the left. When I subtract 5 from the right, I am left with only 2x. When I take 5 away from 18, I'm left with 13. At this point, I am left with 2x is equal to 13. Remember, when we have a coefficient in front of a variable, that implies multiplication. So to get rid of that 2, I need to divide by 2 from both the right and the left side. When I divide by 2 from the right, that leaves me with just x. And when I divide by 2 on the left, that actually we can represent with the fraction of 13 over 2. So I know my value of x is equal to 13 over 2. So this one was actually a 3-step problem. I had that problem, or this step to bring my 2x to the right side. The thinking behind that was I wanted to have a positive value in front of my variable to make my math easier down the line. The next one was to isolate my variable. And the last one was to get rid of the coefficient in front of my variable. All right, on to the last problem. Here we have 3x plus 7 is equal to 12. To isolate my variable, I would start by subtracting 7 from each side. That leaves me with 3x on the left. And then 12 minus 7 is equal to 5. So I have a coefficient in front of my variable, so to get rid of that, I would divide by that same coefficient. That would leave me with x on the left. And on the right side, I would be left with the fraction 5 over 3. Hopefully you enjoyed these practice problems and were able to follow along. And hopefully you picked up something new if you didn't try the hard ones and watched till the end. Have a great day. Thank you for watching.